So the next important aspect under the crystal field theory that could be asked for the competitive examination, that is in the few NEET papers we have seen this, that is something called Jahn-Teller effect. There is Jahn-Teller effect which could be raised. Jahn-Teller effect is basically, it's a JT effect. So they may ask you which of the following complexes shows Jahn-Teller effect, or else they may be giving few complexes and ask you to predict which of the following complexes will be having two different sized length. Two different bond length will be there. For example, they may be giving Cu water 6 times and 2 plus, and if they may be asking whether the Jahn-Teller effect is possible or not, this, or which of the following complex will be having two different bond length. If it is an octahedral complex, if at all you have been given this, the common prediction for us is, thus far whatever we have seen is, this is an octahedral complex. The two of the water molecule will be below and above the plane, rest will be within the plane, that is water and water. So what we are predicting is all 6 bonds, all 6 CuO bonds are of equal size or equal bond length. Do you agree with my point? Because it's a normal octahedral complex, all bond length should be same. All ml bond length should be same. Ml bond length should be same. This is theoretically we expect, anticipate that all ml bonds should be same. But it is not so, students. It's been observed in this particular complex is these two bonds of different size compared to that of these 4 bonds, or length of these 2 bonds will be of different size compared to these 4 bonds. Why so? Why? Because to explain this, the scientist Jahn and Teller has predicted a theory called as Jahn-Teller effect. That is, it explains about why there is a difference in the length of the bond in this complex. There are two kinds of the questions could be raised, because one kind of question is which of the following complex will show Jahn-Teller effect. Second thing which may be asked is, that is, which of the following complex will show two different bond length. That is, we'll just go ahead. What exactly the Jahn-Teller effect is? Jahn-Teller effect is very simple, where in an octahedral complex, this is applicable for octahedral complex, you need to have a center of symmetry for this. In an octahedral complex, if degenerate orbitals are unsymmetrically filled. If degenerate orbitals are unsymmetrically filled, it's unstable and degeneracy will be removed, or symmetry will be distorted. This is what is called as Jahn-Teller effect, not a very complicated, simple one. That is, what it says is, if at all you are having an octahedral complex, if the orbitals are symmetrically filled, octahedral complex, if the degenerate orbitals are unsymmetrically filled, it is unstable. And the degeneracy will be removed and symmetry will be distorted. It will be no longer having the center of symmetry, or the center of symmetry will go. Right? Very simple, not a difficult one. We'll take, student. So what the Jahn-Teller effect says is, for instance, if at all I am having a octahedral complex, I have a T2G orbital at the lower end, EG orbital here. So if I am filling the T2G orbital like this and EG orbital 0, no electrons are there, what is the electronic configuration? T2G3 and EG 0. If this is the case, there is no question of the Jahn-Teller effect. Right? So because Jahn-Teller effect happens only when in an octahedral complex degenerate orbitals has to be unsymmetrically filled. That's it. That is, see, look at here, you have triply degenerate orbital. It is not unsymmetrically filled, it is symmetrically filled. Each orbital is taking one electron. That means there is a symmetrical filling of the degenerate orbital. There is no chance of the Jahn-Teller effect. If at all they are giving the complex like this, for instance, I can write, that is, we can take it as vanadium complex can be taken. Vanadium, hexa vanadium plus 2 complex. What is this? That is, it is a D3 system. This is a D3 system. Right? How many electrons you have? 3 electrons you have. T2G3, EG0. This particular complex, does it show Jahn-Teller effect? Does it show Jahn-Teller effect? If someone asks you, that is, the answer is no. There is no question of the Jahn-Teller effect. Why? Because, take a look at here. That is, 3 electrons you have to fill it at the lower energy level. Lower energy level is T2G orbital. You have 3 T2G orbital. Each orbital is taking 1 electron. That means there is a symmetrical filling of the lower energy orbital. If there is a symmetrical filling, there is no question of the Jahn-Teller effect. The degenerate orbital, that is triply degenerate or the doubly degenerate orbital, should be unsymmetrically filled. For instance, instead of taking vanadium complex, let me take a chromium complex, students. Cr, water 6 times 2 plus. First check whether it is an octahedral complex or not. Jahn-Teller effect is applicable for only our octahedral complex, not the tetrahedral complex. Chromium plus 2, D4 system. How do you fill it? 1, 2, 3, and it is a weak ligand. You will go up and fill here. Right? Just take a look. That is, triply degenerate orbital is symmetrically filled. There is no question of the Jahn-Teller effect. But take a look at the doubly degenerate orbital or the EG orbital. EG orbital electronic configuration, you write it as 1. That means 2 of the EG orbital you have. Out of the 2 EG orbital, 1 orbital is singly filled, another orbital is having no electron. That means there is an unsymmetrical filling of the degenerate orbital. That means what happens is, there is a Jahn-Teller effect possible. Degenerate orbital, if it is unsymmetrically filled, supposed to be unstable, degeneracy will be removed. That means this orbital will be again splitted. Got it, right? That is, one of the orbital will go up, another orbital will come down. This orbital will come down, 1 electron it will take, another orbital remains empty. That is what is called as Jahn-Teller effect. Octahedral complex, degenerate orbital unsymmetrically filled, unstable, and degeneracy will be removed, and symmetry will be lowered or symmetry will be disturbed. If at all someone asks you whether this complex shows Jahn-Teller effect or not, yes. Got it? Got the point? I will take, instead of chromium, let me take manganese, students. Let us take manganese. What is the system? D5 system. If I have a D5 system, how do you fill it? 1, 2, 3, and I will be filling 4, 5. Take a look at the EG and the T2G orbital. T2G orbital having 3 electrons symmetrically filled. EG orbital 2 electrons symmetrically filled. Both the orbitals are symmetrically filled. That means degenerate orbitals are symmetrically filled. No question of the instability, no question of the Jahn-Teller effect. That means this particular complex doesn't show Jahn-Teller effect. Instead of manganese, let me take iron here. Fe, water 6 times, let me take it. What is this system? D6 system. 1, 2, 3, 4, 5 and 6th electron. Just take a look. EG orbital is symmetrically filled. There is no question of the Jahn-Teller effect. But take a look at the T2g orbital. T2g orbital is unsymmetrically filled because one of the orbital is having 2 electrons, rest of the 2 orbital is having 1 electron each. That means to say that this particular complex shows Jahn-Teller effect because T2g orbital is unsymmetrically filled. Degeneracy will be removed, or in other words, there is a splitting happens, students. That is, one of the orbital comes down, rest of the 2 orbital goes up. That is, again there is a splitting happens. That means degeneracy will be obviously removed, and degeneracy removes means symmetrically the system gets lowered. That is, what happens is the bond length varies. That is, 2 of the bond will be having one particular length, rest of the 4 bond will be having different length. Very, very significant point. Which of the following complex shows Jahn-Teller effect? If at all somebody asks you, you can straight away hit the answer, check whether any of the orbitals are in the octahedral complex are unsymmetrically filled or not. If it is unsymmetrically filled, it will show Jahn-Teller effect. So similar way, if you take the cuprammonium, copper, hexa-aqua copper 2 complex, if you take a look, it is a D8 system, students, right? It's a D9 system. It's a D9 system. D9 system, octahedral complex, quickly will rush through T2G3, T2G orbital 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? This is the electronic configuration of this particular complex, that is T2G6, EG3. That means if you take a look at here, T2G orbital is symmetrically filled, but EG orbital is unsymmetrically filled. Again the EG orbital will split into 2 parts. That is, the degeneracy will be removed because these 2 degenerate orbitals are unsymmetrically filled. Jahn-Teller effect supposed to operate here, or in other words, there is a splitting happens, or the degeneracy will be removed, or symmetry of the system will be lowered, or 2 of these bonds will be of different length, whereas these 4 bonds will be of again one more length. I mean, these 4 bonds will be of one length, whereas these 2 bonds will be of different bond length. Very, very important point, Jahn-Teller effect. That is the end of the Jahn-Teller effect for you. That is the end of the Jahn-Teller effect for you.